Hello everybody, I hope you're all as eager as I am to start a brand new math contest. We're going to be looking at the 2011 Hypatia contest. You can get a copy for yourself by clicking the link in the description, the first link. The second link will take you to the CEMC website, the CEMC, or Center for Education in Mathematics and Computing. They're from the University of Waterloo. They're the one who make up all these contests, so the second link is their website. You can try all the contests that they have, not just the 2011 Hypatia. But, as I say, I do encourage you to download this contest, try it on your own. From memory, I believe we get 75 minutes to try it. It is a written contest aimed at grade 11. It's sort of a 4-question contest to help prepare you for writing solutions more for the Euclid contest, which is the grade 12 written paper. Okay? But as I say, practice, 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 download it, try it, practice for yourself, and then come back and watch the video or videos of me going through the Hypatia if you need answers or want to learn different ways to do questions. Okay? But I'm going to assume that you've paused the video and done any and all of that. And we're going to take a look here at question number 1 on the Hypatia. Okay. So in the diagram, D and E are the midpoints of AB and BC respectively. And I look at my diagram, I notice they have given me coordinates for A, B, and C. I notice that AB is length 6, BC is length 8, and that tells me AC is going to be length 10 because it's a 6, 8, 10 right angle triangle. Remember that the axes always make a right angle. Okay, whether or not that information is going to be useful, I don't know. But now I'm starting to see AEB is going to be right angled, and DBC, that's going to be right angled. So there might be some Pythagoras going on here. We'll see. We've got 4 parts to this question, and we do, because it's a written contest, we do have to write everything up. Part A, determine an equation of the line passing through the points C and D. Okay, well we know D is the midpoint, and since we have the coordinates for A and B, we could actually write down coordinates for D, and since it lies on the y-axis, we can actually pretty quickly get a y equals mx plus b sort of situation. So we'll go into our notepad. We got a fresh one here for the 2011 Hypatia. There we go. So we'll select the dark black and draw a copy of our picture. Might have to draw that a couple times. This might take more than one page. C was 0, 8. B, obviously 0, 0. It's the origin. And A, 0, 6. So now D is halfway between here, and E is halfway between here. So I imagine since they told me that E is the midpoint, I'm going to eventually need to know its coordinates. I figure I'll work them out together right here. Oh yeah, coordinates of D and E are... So how do we figure out the coordinates of a midpoint? Well, you add up the x coordinates, divide by 2, and you add up the y coordinates and divide by 2. So D is at 0, 3, and E is the midpoint of B and C, so we get, this should be 8, 0. There we go. So 0 plus 8 over 2, 0 plus 0 over 2, so E is at 4, 0. If we connected them up, we'd have a nice little 3, 4, 5 triangle. So I've got the coordinates of D and E. I'm never going to have to recalculate them again. And I want the line DC. Okay. Well, we'll use the y equals mx plus b formula, in which case then we know what b is because b is the y-coordinate of the y-intercept, and so it's going to have to be 3. So we could even say that. B equals 3 as d is the y-intercept. Okay. Now the real question is, what is m? And there's a couple ways we could figure out m, and we've got the coordinates of D and C, so we could certainly do sort of a rise over run situation. Another way to figure out m is plug it in. Well, you can't plug in d because then you're going to get m times 0 plus 3 is equal to 3. Not very workable, but we have a second point. So I'm going to say c lies on the line. So y is equal to mx plus 3, or really the 0 is equal to m8 plus 3. So negative 3 is m8, or negative 3/8 is equal to m. So our line from C to D is given by equation y equals negative 3/8 m plus 3. Okay? And if you'd wanted to, you could have done sort of rise over run, 3 minus 0 over 0 minus 8. You're still going to get negative 3/8. That's okay. But we've got our answer here. And that's the answer to part A. Alright, so D, determine the coordinates of F, the point of intersection of AE and CD. Okay. Well, how do we figure out points of intersection? Well, if I had the equation of both lines, CD and AE, I'd be all set. Now, I don't have the equation for AE, but I do have the equation for CD. We worked that out in part A. So that sort of gives us half of what we need to do. So the rest that we need to do, figure out the equation of AE. That's going to be just as quick as it was in the A part. And then set those equations equal to each other, and we'll find F. Okay. So, let's get to it. So what would be the best way to do it? So, let's find the equation of AE. So I know A is the y-intercept. So we're going to have y equals mx plus, well, the y-coordinate of A was 6. And then I know E, which is 4, 0, is on this point, or is on this line. So E is on the line. So 0 is equal to m times 4 plus 6, or negative 6 is m times 4, or negative 3/2 is equal to m. So AE has equation y equals negative 3/2 x plus 6. Okie dokie. So we have the equation for AE. I'm going to also use the equation we worked out for CD, negative 3/8 m plus 3. Y equals negative 3/8 x plus 3. I did copy that right, correct? Oh. I thought I said m aloud. Okay, it's x here. Alright. But there we go, negative 3/8 x. So to find f, equate the expressions. So we'll have both y's are obviously equal, but negative 3 over 2x. The expressions in x have to be equal. I think I'll multiply everything by 8. So we get negative 12x plus 48 is negative 3x plus 24. And then 24 on this side, bring the 12 over the other side. 12 minus 3 is 9x. So x is 24 over 9. Now 24 has a factor of 3, so does 9, so we get 8 over 3. And y is equal to, doesn't matter which one we go with, but we'll do negative 3/8 times 8 over 3, just so everything cancels out nice and neat. Negative 1 plus 3 is equal to 2. So F has coordinates 8 over 3, 2. And if we wanted to, we could even double check that this is the case by plugging in our x value into the AE equation as well. The 3's will cancel out. The 8 over 2 is a 4. We'll get negative 4 plus 6, and that also uses a y coordinate of 2. It's nice little extra things that you can do like that. Plug your f coordinate in, make sure it's on both lines, just to double check your work. It's not that hard to plug in. Does this point actually exist on both lines, or have I made an algebra error? And that can certainly help you as you're writing things up. Usually checking isn't worth marks, but checking is how you know you're not about to lose marks because you rushed through some algebra. So just something little to keep in mind. Okay. So that's B part. Now C and D. C, determine the area of BCD. Well, that's not going to be that hard. Height of 3, base of 8. All right, so that we'll move on from there. Determine the area of the quadrilateral DBEF. DBEF, okay. In terms of doing D, I think probably best, since based on C, where we have to figure out DBC's area, probably if we do ABE's area, add the two together, and you'll get an extra copy of DBEF, or, no, actually, no. So here's what I'm going to do. For C, I'm going to determine the area of DBC, and then to compute the quadrilateral, it's just that area, that triangle DBC, subtracting off FEC, and then since I know the y-coordinate F, I know the height, and I know the base because it's halfway point, so it's going to be 4. So we'll be all set. Okay, so let's do both of these, C and D. Okay. So to compute the area of DBC, we use 1/2 base times height. The base is equal to 8, and the height is the y-coordinate of D, which is equal to 3. So the area is equal to 1/2 base times height, so that's 1/2 of 24, or 12. So now I'm just going to redraw my picture. We can draw a better picture than that, can't we? There we go. F. Okay, so we want the blue area, this quadrilateral. That's what question D is asking us for. Now from C part, I know the big old red triangle. And now in this part, all I'll need to do is calculate this smaller green triangle. But it has a height of 2 and a base over here of 4. Okay. So the area of DBEF is equal to area of DBC minus the area of FEC. Okay, so this is 12 minus 1/2 base times height. This is 12 minus, and you would either need to explain that the base is 4 and the height is 2, or I think a picture works just fine as well. 1/2 base times height, so it's going to be 12 minus 1/2 of 8 is 4. And so our final answer is the quadrilateral here has area of 8. Okay. Neither of those were particularly computationally extensive. As long as you had a nicely labeled picture, I think everyone would give you all the marks for that. And we've run out of stuff to do in question number 1. So we are 1/4 done the contest. And in the next video, we're going to take a look at question number 2. So if you haven't already paused the video and downloaded a copy, well, don't pause it now because the video is about to end. But do download a copy of the contest. Try it for yourself. Try it with a friend. But the best way to practice these contests is, well, to actually practice them. The best way to do well on future contests is to practice old ones, practice similar problems on your own. Try them on your own rather than just watching somebody do them. Okay? And I will see you guys for question number 2 in the next video.